Hi guys, I had some questions before we went on Thanksgiving break about this worksheet, chemistry worksheet, limiting reactant moles, right? And this goes along with the example that I just posted in Edpuzzle, limiting reactant examples, moles. And I'm going to go over the first one with you, and then we're going to check in tomorrow. And I want you guys to try to do number 2 and number 3 on your own, and then we'll check and see how you did. So a couple of things to remember about a limiting reactant or limiting reagent problem is that you are always going to have 2 givens in your problem. So in this equation or reaction, on part A, it tells us we have 3.22 moles of aluminum reacting with 4.96 moles of HBr. And we want to know how many moles of H2, which is a product that we're actually going to make. We want to know what is our limiting reactant. And once we know our limiting reactant, we want to look at our excess. Excess is the one substance on the left-hand side, or the one reactant that you're going to have left over. So we want to know how much is going to actually be left over. So one of the things I like to do is, it's very important, this equation that we have, is I have 3.22 moles of aluminum. And I always like to write those above what they belong to in the equation. And then I also have 4.96 moles of HBr. All right, so those are my 2 givens. Now, we're going to answer these questions. It doesn't necessarily mean that I have one that I have to do first, but if we go ahead and go by our example, if I calculate how many moles of hydrogen I can produce, that will in turn tell me what my limiting reactant is. So, remember I have to do 2 small train track problems. So, I'm going to start with aluminum first. I am going to do a mole ratio between aluminum and hydrogen because that's my end goal. I want to know how much hydrogen I can produce. So remember, we're going to look at those coefficients that we see in front. So I'm going to start with 2 moles of aluminum on the bottom. All right, I'm looking for hydrogen, so my coefficient is 3 moles of hydrogen on top. All right, so I'm going to plug that into my equation. I'm going to take 3.22. I'm going to multiply that by 3 for 9.66. Moles of hydrogen on top. 1 times 2. All right, and then top divided by bottom. We get 4.83 moles of hydrogen produced if I start off with 3.22 moles of aluminum. Now, I have a second given, so I'm going to do the same thing. Now I'm going to use 4.96. So I have 4.96 moles of HBr. I'm going to do a mole ratio again between HBr, and in this time I have 6 moles. It's going to go on the bottom of my train track. And I'm still looking for hydrogen if I'm going to start off with that much hydrogen bromide. So I've got 3 moles, H2 on top. All right, so I'm going to multiply through 4.96 times 3. And I get 14.88 moles of hydrogen. 1 times 6. All right, and then we're going to go top divided by bottom for 2.48 moles of hydrogen. I'll run out of room. All right, so we calculated how much we could make. And remember from our Edpuzzle, this is the point where when we look at these numbers, we always go with the smaller amount. So this is actually how much hydrogen I can make because 2.48 is smaller than 4.83. And then we're going to go back and look to see what we started with that allowed us to only make that much. So HBr is what I started with. So HBr is limiting, or you can say limiter, either one. And if HBr is our limiting reactant, it means the other reactant, which is aluminum, is our excess. All right, so by doing that calculation, we actually answered 2 of the 3 of the questions that we wanted to answer. Our last question said, how many moles are we going to have left over at the end of the reaction? All right, so to answer this question, we know that aluminum is our excess, but how much of our excess are we actually going to use? So to answer part C, we want to start with how much of our limiting we actually have. So our limiting, we actually have, since it's HBr, 4.96 moles of HBr. So I'm going to start with that. All right, and then we're going to do a mole ratio. And where do mole ratios come from? They always come from your balanced equation. Except this time, I don't want to see how much I can make. I'm going to see how much I can use of aluminum. So my mole ratio is going to be between HBr, and my equation tells me I have 6, right, and aluminum. Oops. All right, I apologize there. I almost cut everybody off, so hopefully you can see that. All right, so we're going to multiply through. So we have 4.96 times 2. All right, 1 times 6. And then our top divided by the bottom. And we end up with 1.65 moles of aluminum. All right, so this is how much aluminum I'm actually going to use for my problem. All right, in my problem, we learn that I have 3.22. So to find excess, it's always a have minus a need. I have 3.22 moles of aluminum. I only need 1.65 moles. So when I subtract, I end up with 1.57 moles. And that is how much I have left over. All right, guys, so go ahead and try number 2 and number 3 on your limiting reactant moles worksheet, and we will check in tomorrow to see how you did.